Welcome back. And on this video, we are going to do a Monte Carlo simulation that works with a set of data parameters, then the income statement, which then we get the cash flows, and we eventually get NPV. Now, we have worked with this data on previous videos when we did sensitivity analysis. However, the difference here is this piece. In sensitivity analysis, we had a set number, and then we changed each one of them by certain percentage. On this scenario analysis that we're going to use Monte Carlo simulation, we have now an average, an expected amount, and a standard deviation associated with that amount. And then, and we'll talk about this in a minute, we will do a simulation based on these factors and a random probability of it happening. So now for the initial calculation, we just have the expected, the average is in the middle, and that's all we're using. So it's important to understand that when we calculated these income statements and projected them, we used those numbers from here, for example. The variable cost, which is 60% of the sales. So we didn't use these here. We're using the ones that we're populating here. Let me see. For example, we're also going to talk about another one that changes, which is the terminal line of value, for example. And the building and equipment, when you sell it, those come here at the end. Other ones that are influenced are the unit sales growth. So notice that we have this one here involved. We do that one. Okay, so that said, what we will do is then work with these numbers in a simulation first, and then add a Monte Carlo situation, a Monte Carlo simulation of multiple scenarios. Okay, so what we're going to do is right now only have those averages in there. So instead of those, we're going to change this so this simulation recalculates according to these two values to give you different potential outcomes. And the way we do it is, we are going to use a function in Excel that is, so we're going to change this to normal distribution inverse. And the first one is asking for is a probability. So we're going to use random probability. So when you put in this function rand into parentheses just empty, what it does, it randomly assigns a different probability every time it recalculates. Then it wants to know the mean. So the average that we're going to be working with, that'll be our expected value. And then the standard deviation, which we have here. And what that's going to do now is going to recalculate it in every potential scenario that it may go up and down according to the standard deviation and some kind of random probability. So we can do at that point is just drag it down. So then now it applies the same for each one of these. It's going to get the same formatting done. And what you're noticing is that every time we interact with Excel, it may update to give you a different simulation. And that's fine. No need. There's a way to stop it from doing it, but no need for that. Once we get to the Monte Carlo simulation, we'll revisit why we want to allow it to recalculate every time. Okay, so what happens is that these are changing based on certain probability and the standard deviation and the average. So saying, okay, what happens if we don't get 350,000 for the terminal value? Then we get this much. What happens if the price per pound is not 250, but ends up going up to 259? And so on and so forth. What happens if these things change according to certain probability and standard deviation? So as those numbers change, because we have them all linked up here, it means that this is going to update the cash flows that are being calculated. And then once those cash flows are calculated, then you can calculate a net present value, and it gives you that number. So notice that every time we recalculate, I'm going to hit F9 to recalculate. Every time that recalculates the simulation numbers is going to give us the new NPV according to these changes. Now, these tables are pre-built. If you want to see how we built them, you can go to previous videos that we have when we did the sensitivity analysis and we built these tables to get the cash flows. So what I can do right now, I can slowly go one by one so the video captures the formula up here and you have a better understanding of where these numbers came from. Now that's for the first set. And then here, notice how those were calculated as we go down. And then it just repeats itself. This initial one had to do with the initial outlay. And then the only thing that is then different over here is this terminal cash flow, which has to do when you sold equipment. And that is the formula that we followed using these values. And then for the total annual cash flows, all we do is we added whatever cash flow situation we had in each one of those. And then for the NPV, that's what we used. Okay. All right. So moving along to get into the actual Monte Carlo simulation. What we want to do is now, as we did in the previous video with the profit example for Monte Carlo simulation, we're going to go ahead and talk about these trials. So this one here is pretty much, when we use these numbers, it impacts these and it changes this one. So that's like our preset simulation. Now we're going to do, let's say, 1,000 different trials and simulations. So as we saw in the previous video, I can put a 1 there, right? And then what I do is I go here, fill, series. I'm going to go to columns because I want it to go down. Step value 1. And then I'm going to put 1,000 here. And I hit OK, and it populates all the way down there to 1,000. All right. Now, what we want to do now is equal this one to our first simulation that we have here. So whatever the simulation says here, we'll always have the same number there. If I recalculate, I'll hit F9 and does that. Another place you can recalculate is go to formulas. You can hit calculate now. And if you hit calculate now, it will then run another simulation. Okay, so now what we want to do is do the same thing 1,000 different ways, 1,000 different simulations, and to populate all the way down. So you want to select these 2 cells. You need them both selected. Okay, we're going to go here to data, and we're going to go to what if analysis. And we want to build what we call a data table. Once you select that, since we're doing columns, ignore the row. So let's go to a column. Now, as we explained in the previous video, all you're going to do is pick any blank cell that doesn't interfere with other calculations. And it's just a place for Excel to work with, and then populate the table all the way down. Now, before we continue, let's go ahead and restart that piece, because what we want to do is to have all these 1,000 ones highlighted. So I can either go like this and go all the way down to 1,000, or I can just have these 2 highlighted. I'm on a PC, so it's going to be Control Shift and the down arrow, and it's going to automatically highlight all the way to 1,000 where I stopped. So now that we have them all, now Excel knows that the data tables I want to populate is the highlighted portion. So let's go back there. What if analysis, data table. We're doing columns, not rows. And once again, just pick any blank cell that is not interfering with any calculation. Hit OK. And now it knows that you want this to be done 1,000 times all the way down. And that's what it did. So now we want to know, out of all these 1,000 potential NPVs, any of these have some probability of happening. So we want to know what will be the average based on any of these happening over and over and over 1,000 times. So I can use the average function, and I know E34, and I'm gonna put the dollar signs by pressing F4 so I can lock it in place, all the way down to E1033. And that will cover 1,000 cells. I'm also gonna put dollar signs to lock it in place. Now we can do a quick check if you want to make sure we did catch it all. There it is, 1033 is the cell, but we went from 1 to 1,000. So I'm gonna hit enter, and there it is. So now, since I'll have the dollar signs locking those in place, I'm just gonna drag it down and then adjust them as needed. Let's do a little formatting. So it looks nice. Now, of course, right now we have all of them showing the same number because all of them are average. So what I'm gonna do is I'm gonna change now the function to whether standard deviation, minimum, and maximum. The reason I did that is so it keeps this range here in place a lot easier than highlighting every time. So here I want a standard deviation. So I'll just change that to standard deviation. We like going with S for sample. Hit enter. We're gonna go ahead and we want minimum here. Hit enter. And what that's doing is give us the lowest number from all these 1,000 trials. Here we're gonna do a maximum. Hit enter. Here we can do skewness, and we'll talk about that in a moment when we do the histogram. Here we're gonna go with Kurt for kurtosis. And risk of loss of value, in other words, a negative, what's the probability of getting a negative NPV given 1,000 trials? What we do is we wanted to count the negatives. So I'm going to do count if is going to ask us for the range. We already have the range in there, those 1,000 cells, and then it wants the criteria. The criteria is it less than 0? In other words, negative. And we put the quotation marks to understand as we want. And then in order to do it as a percentage, we want to divide it by the 1,000 that is observing. So it counted the negatives in that 1,000 divided by 1,000. Then we change this as a percentage. Do it a couple. So there's a 2.9% chance that you may end up with a negative NPV. That's fairly low. That's not a bad risk of loss of value. So this project is pretty stable, pretty safe that there will be added value. Sometimes more, sometimes less. But, and in some occasions you may have losses, but it's very low probability of that happening. Now let's go ahead and as we did before in the previous video, we're gonna do a histogram. So I'm gonna Control Shift arrow down so it highlights all 1,000. And then I can go to Insert. Here in the charts, go to All Charts, go to Histogram. And it shows us the curve of that probability distribution. Kind of follows a normal distribution. And that's where skewness tells us how it shifts left or right. And kurtosis tells us how steep this peak is going to be. So you notice if I hit F9 to recalculate, once it runs through another iteration, it changes a little bit, and these numbers change, letting you know how those work. Now, in this course, we're not discussing the details of how to use QNIS and kurtosis, but now you know it's something available to you as another tool. And notice how our risk of loss value went a little higher now. And that's Monte Carlo simulation. When you have data set up in this way, you can calculate the cash flows. Once you have the cash flows, then you get the net present value, and then you can run simulations and then many thousands of trials at a time and get some more information on your net present value. We will stop the video here. See you on the next one.